Alright, hello, welcome back. It is the 22nd of August. Over the weekend, I did want to do a little bit more of these problems, but basically things happened and I wasn't able to do that. But I'm back now and ready to do a little bit more learning here. So we're going to try and implement this repetitions using, I guess, C/C++. So we have a problem here. We are given a DNA sequence, a string consisting of these different characters, and we need to find the longest repetition in the sequence, and also basically say how long that repetition actually is. So that's doable, I think. I think this may end up being one of those things where if you don't practice every day, you suddenly find that you forget most everything. But I'm just going to go ahead and try typing a solution here. So what you actually get is a potentially very long string. Oops. So up to 1 million characters. And you have to find the length of the longest repetition of letters. So in that case, it's 3, because there's 3 G's there. So, I mean, I think this is maybe easy. Although, no, I think you're fine in terms of the memory limit. So if we were to do actually, let's use namespace. And let's let's load up a string, and I assume that you can actually actually, why am I'm already using namespace std. I assume that you can actually access a index of a string like that and not really have that be a problem, I hope. So let's actually see if we can do that. Yes, you can. Okay. So in that case, I guess we want a for loop. And then inside that loop, actually, I guess we also want to have something that can actually store the longest repetition. And then we're basically going to be iterating over the characters one by one. And as we go up, we kind of want to have like a current character. So I guess we should probably assign that up here, and then do so we'll assign the character, I mean, maybe I don't need to cast it, but the string at the index of I will assign to current. And then I don't think we can necessarily count ahead. We also want to have a count as well, which I'll initialize to 0. I mean, I could actually just set this current character to the first character of the string, and then actually just get this to start from index 1. So actually, before we assign that, we should probably check that where we are right now is the current letter. So we'll set count to 1. So this is kind of like our first iteration that just initializes everything. And then we want to say that if our current character, which is cars at I, whoops, I'm still thinking I'm using my Mac here, so I'm doing that, is equal to current, then we can basically increment our count and then continue this loop and move on to the next one. Otherwise, I guess this is where we're going to want an else. We want to take our current count of how many characters have matched or have been like sequentially the same and compare that to longest. Which actually longest should be 1 because that's what it repeats as. But we only want to reassign longest if the count is longer. So if count is greater than longest, then longest equals count. Then we reset count back to 1. We also need to reassign current up here as well. And then continue the loop. And then basically once the loop is finished, we just output the longest character. And I think that should work. I mean, let me just review this again as before we compile and try it. So our longest sequence is 1 because we assume that we're taking the first character in the string, so the length is 1. The longest may always be just 1. Then we're setting our current like letter that we're looking at to be the first element in the string, and we're setting our count to be 1 as well. And then we iterate over all of the characters. I hope that size of is what we do there. I don't know if that's the right way of getting like the full length of a string. Starting from index 1, because we've already dealt with index 0. And then this is actually the letter we're analyzing. If it's the same as our current letter, then we can say that there's 2 of them, for example. Or we increment the count In fact, I don't even need to do that. So I can remove that there. But if it's not the same, and our count has become longer than the current longest sort of record, then we set longest equal to count. We reset count back to 1, and then we set current to whatever character we're dealing with right now. Okay, I think that should work. So, oh, okay. Long unsigned int. Okay, that's fine. I can just initialize that as a long unsigned int. So then if I was to give it this input, we should see 3 as our result. Whoops. No, not that. That. Okay. It's saying 10 is our answer, which is obviously not right. Is that the 1, 2, 3, 4, 5, 6, 7, 8? So I don't know where 10 is coming from, actually. Maybe I have a typo somewhere. I mean, I don't know why I have that continue there either. That's not necessary, because if that doesn't pass, then that won't pass either. Let's do like... and count is count. There we are. I think those are probably the things that we're going to want to print debug. Character constant is too long for its type. What? What does it think that's a int? Ah, okay. Whoa. Guess it's not a fan of single quotation marks. That could make a good question actually for something like ChatGPT, because I didn't know there was a difference really. Okay, so that's fine now. Alright, so let's copy this and then paste that in there. Interesting. Okay, letter is 1. Okay, yep. Okay, I actually think the logic is right. It's just we don't do size of cars. Because it seems to just do whatever. So, okay. Get length of string CPP. We use dot. Ah, okay. So you can use dot length if it's a std string. Okay. That is probably a lot easier. So instead of that, we'll do length and call that method there. Okay, and then this should be okay. 3. So that is the correct answer there. Hopefully this implementation is good enough for this submission. Let's see. So let's go ahead and submit that. Okay, I have wrong answers. Even in test number 1, I have wrong answers. How do I have wrong answers? User output is 1. Okay. It doesn't actually seem to... Oh, okay, I see what's going on here. Basically, if we never actually we only ever reassign longest if this changes. So we should actually probably put something... We should have that same statement here at the end of the loop, that if count is greater than longest, then we actually want to reassign longest to be the value of count. Because this is wrong. And I think all of these... Oh my god. That's so many characters. That one's exactly the same, so it should be 1 million. Or whatever that is. 100? No. Million? Yeah. Or 10 million? Whatever it was. This one's all the same, but you can see that longest never becomes 1. So we'll just do that at the end and see if that works. So let's try. Also, I don't think if the longest string is at the end, that's correct either. So I think that's still wrong. But let's test it against... Okay, let's test it against this simple one here. Hope I recompiled. Okay, 10. So that's fine now. This, I think, is still wrong. I don't think we've solved for this issue. Oh, or maybe we have. Okay. So in that case, let's try resubmitting now then. Okay, brilliant. Nice. Okay, so let's do the next one. Increasing array. So you are given an array of n integers. You want to modify the array so that it is increasing, i.e. every element is at least as large as the previous element. On each move, you may increase the value of any element by 1. What is the minimum number of moves required? You may increase the value of any element by 1. The minimum number of moves be up to 20,000 was... Oh, actually yeah, okay. And your numbers can be massive, potentially. Okay, so this is apparently 5. So you have a minimum number of moves 5. You may increase the value of any element by 1. Okay. What is the minimum number of moves required? So I think this. So I think you'd have one move here to make this 3, right? So that would be one move. That's fine, we don't need to do that. Then you would have 4 more moves to make that 5. And then that one you can leave because you would basically have 3, 3, 5, 5, 7. And because this one is larger than that one, then that works. Okay. So let's see. So let me actually put that into code. Or, sorry, let me actually kind of make notes on that. So 3, 3, 5, 2, 7. Move 3, 3, 3, 5, 3, 7. Move 4 is 3, 3, 5, 4, 7. Move 5 is 3, 3, 5, 5, 7. So it looks like what we're doing is we iterate from the beginning of the array plus 1. If let's call this I. So if array at I is actually equal to, or greater than, or equal to the array at I minus 1, then we can actually just continue. But if the array at I is less than the array at I minus 1, we need to increment the array at I and increase our move counter, or increment our move counter as well. But we actually need to stay in here. So repeat above until the array at I is greater than or equal to the array at I minus 1. Or actually, I mean, the minimum number of moves mean we'd want to do it till it's fully equal. And then once done iterating, print move counter. I mean, I think that's what we would do. I don't think there's any real like trickery there. So yeah, let's go ahead and give that a try. So let's do include IO stream. Probably not going to need anything else, so that's fine. So let's do unsign n. Let's get our n, which is the size of the array. Use namespace std. And then we can get our array here. Didn't I have like actually probably able to use the we can probably use this trick from before. Or actually, I mean, we can say new. So we'll say unsigned array new unsigned. Is that how we declare it there? Hmm. Let's see. Oh, right, okay. Oh, okay. I guess that makes sense. So we can just that for the moment. But then we can say that for unsigned I equals 0, while I is less than n, we increment I. We just say array at I we'll just assign to the array at I. So that populates our array, which I'm hoping is not immutable. I don't see why it would be. And then we want to kind of do like a double loop. I think one of the loops would be a for loop. Because we want to have something that kind of takes us through the length of the array. So I'll do a similar kind of unsigned I equals 0. I'm not going to iterate over the array in terms of the elements themselves, because we want to kind of be able to navigate. We want to know where we are in the array. So I'm going to say, you know, similar loop here. For unsigned I equals 0. Okay, yeah, of course. So this actually needs to be I equals 1, because we don't want to start at the very beginning, because we won't be able to look back. So that's fine. So let's do kind of what we've commented up here. So if the array at I is greater than or equal to the array at I minus 1, then we can actually just continue. Otherwise, if the, well, we don't even need the if. We actually need a move counter as well, which will initialize to 0. Otherwise, we need to kind of repeat that. So whilst the array at I is less than the array at I minus 1, we want to increment the array at I and also increment our move counter as well. And then at the end, we want to print our move counter. Yeah, let's see how this works. I need to actually put this in the right folder. Increasing array. So we have 5, and then 3, 2, 5, 1, 7. And it does say 5, so maybe that worked. So let's do increasing array. Let's see if it can handle all of the other test cases. Okay, so one of these is a little bit too slow. Yeah, so it stops them because they were too slow. Okay, so if that's the correct output, I don't think we can increment that many times. But what we can do is make it much more manageable, right? Also, I mean, how big can our array be? I mean, that can probably be that, but the values can be absolutely massive. So these are going to be long longs, as is our move counter. Actually, there'll be long longs because they are big numbers. What we can do quite simply is take the difference and then that's our move counter. So we would have to do, yeah, we would take the previous element value, so in this case 3, subtract it, or subtract this value from that. So we would say array I minus 1 minus array at I, and then that gives you obviously 1. That's our 1 move that we add to the counter. Yeah, and then we have we count 4 there. Okay, so actually we don't want to have a while loop, but we want to say this could also be a big number. So the difference is the array at I minus 1 minus the array at I. And then we simply say move counter, and then we just add diff onto move counter. So that's from attempt 1. So take the difference of array I minus 1 and array I and add result to move counter. I think that should work. So let's see. Let's try it with the simple example to begin with. 5. Okay. Let me try submitting that again. So increasing array. Ah, now we've got wrong answer. It's only... Oh no, we've got completely the wrong answer. Unless it, unless you never have to do anything. So that is the correct output there. This is my user output. Kind of like orders of magnitude smaller. Okay. Wow. Okay, that is interesting. The issue is I don't really have a good test case to debug this against. I don't know if I want to do it with the 200,000 ones. Could try this one, which is a bit more simple. Oh, I think I know what I'm doing wrong, actually. I'm not reassigning the array at I. So if I said array at I is array I minus 1, then that might actually work. So let's try with like this nicer example here. Okay, that is correct. So let's actually try submitting that again. Yay. Okay, great. That's good. I probably do have time for one more. Depends how long it takes. So let's just give it a try. So this one's called permutations. Okay, so a permutation of integers 1 to up to n is called beautiful if there are no adjacent elements whose difference is 1. Given n, construct a beautiful permutation if such a permutation exists. The input line only contains one integer, contains an integer n. If there are, okay, if there are no adjacent elements whose difference is 1, so for every number between 1 and your input, okay. Here I think I'd probably want to do this with, see how you could do this with some different examples. So maybe something like 10 and then like 13. So if you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then like how can you rearrange that? I mean, we could do like 3, 1, 4, 2, 7, 5, 6, 9. See, I don't think you could do it for 10. Because all you're left with is 8 and 10. Unless you can rearrange some of these. See, because it might be possible because you could do 3, 1, 4, 7, 2, 5, 6. Oh wait, no, you can't even have 5 and 6. It would be 5, 9, 6, 8, 10, which means you can do it. Right? So 3, 1, 4, 7, 5, 9, 6, 8, 10. Yeah, so that actually works. And we basically got there just by borrowing from n plus 1 plus n plus 2. So you're kind of like taking numbers from ahead to drive a wedge in between. And then maybe working backwards. Don't really know how we got there. Yeah. Quite difficult, really. Unless there's a clever way of figuring that out. So 10 and 5 are fine. But see, you can't just say, yes, it's a beautiful number, or no, it's not. You have to actually print a sequence. So we still have to figure out how to go about actually constructing this. And to be honest, I'm not too sure. Starting at 1, ending in n. If no adjacent numbers exist. I'm just wondering if there's like a formula or like a dead set way you can actually figure out if something is beautiful or not. Because you could employ, you know, some trickery here where you basically split your array right down the middle. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And you just kind of like shift them together. So your result kind of becomes like 1, 6, 2, 7, 3, 8, 4, 10, 5, 9. That could be a way of doing it, actually, because the only thing you would need to worry about then at the end is if... Yeah, I mean, that's probably how we might be able to do that. But then you would just need to worry about the 3 at the end, which are obviously in danger of being next to each other. So how did we... You know, we sort of added up until the last 2 columns. And then you have 4, 9, 5, 10. So you want to make sure that you're kind of matching diagonally there. So 4 goes next to 10, which goes next to 5, which goes next to 9. So let's say that. On the last 2 columns. 4 matches 9, which matches 5, which matches 10. I don't know, 4 goes next to 9, which goes next to 5. which goes next to 10. But I do want to have a think about actually how we would do this with an odd number. So let's try 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Hang on, I've split this down. Oh no, I haven't. So with this, it would go something more like... Ah, okay, actually, an odd number is even easier because you just tack the 7 on at the end. So we would have 1, 8, 2, 9, 3, 10, 4, 11, 5, 12, 6, 13, 7. And yes, that's a beautiful number. The only thing that I think might be tricky is in numbers where it's not beautiful. But I'm actually wondering if maybe every number is beautiful at this point, except 3 and 2 and obviously 1. I don't know if that's actually a fair assumption though. Because it's based on, I mean, this is based on the evenness and oddness of the number. Because surely this would be true for any even number, and surely this would be true for any odd number. So I think the only non-beautiful numbers are if n is 1, 2, or 3. Well, actually, 1 might be beautiful. But 2 definitely isn't, and neither is 3. Is 4 beautiful? I mean, I don't think 4 is beautiful either, actually. You could do like 3. Oh, actually, no, I take it back. 4 is beautiful. Yeah, you just, again, sort of match it diagonally because you do 1, 2, 3, 4. Oh, actually, hang on. I'm being really silly here, aren't I? This is not 3, 1, 2. Oh, wait, no, actually, 3, 1, 2, 4 works. But this one doesn't. I guess it has to be... Three, 2, 4, 1 works fine. 3, 1, 2, 4 also works. We can use this trick for any number that's greater than, I guess, 5. Well, actually, no, I think we can take this trick from 5 onwards. I guess. I don't know, let me do some typing here. I may actually span this one over 2 days, so try something for the moment and then revisit it later because time is getting on. So let's take in IO stream. We obviously want to use namespace std, and we want to have our main function, and we want to say we want to take in n. Let's say if n is 3, or if n is 2, then we just say there is no solution. But otherwise, I think we probably need to make like an array of pairs and just take, you know, get each number from the first half of the number and then from the second half of the number. So we can kind of like just do a floor division by 2, and just go on as long as we can. So if we said we said our left hand side is n floor divided by 2. Might actually be in math, maybe. Floor. Why? What? In CMath header file. Okay, interesting. So let's do that then. Because isn't there one just called math as well? But this is in CMath. So, I don't know. That's a bit odd. So this is the floor of n over 2. And then the right hand side is whatever's left over. So I mean, is the right hand side actually kind of like necessary there? I don't know. And then I guess let's have a vector. And we also want a pair as well. I don't know if that has its own library. I'm sure it's called a pair and not a tuple in this. It's in utility. So a pair, unsigned and unsigned. And I guess we want to say that like up until we hit the left hand side, we say we pair each integer up. So this is so for unsigned I equals 0 while I is less than n, while we increment I, we can actually say that, you know, if we did a floor division and got 7, which Do I have Python here? I have Python 3 here. Okay, let me just do something real quick, like 13 divided by 2, floor divided by 2. Okay, so that actually gives 6. So in reality, the 7 would come from that side. And you know what, let me just undo that and go back to whatever we were doing. Why is that not working? Undo. Whoa, okay. So actually, more realistically, a representation of 13 would go 1, 2, 3... go to 6, and then we would have 7, 8, 9, 10, 11, 12, 13 on that side. So to get from there to there, yeah, we take our left-hand side limit and then subtract that number, or sorry, add that number to it. So we would say 6 plus 2 is 8, 6 plus 3 is 9, 6 plus 4 is 10. That is 11, that is 12. Until our iterator reaches that. So actually it's until our iterator is less than the left-hand side. And then we can say that if our last element does not have a... Oh, but it's not always going to be a pair though, is it? I guess if we have a trailing element, it doesn't need to be in the vector. It can just kind of be tacked on at the end. I also have like a horrible feeling I'm overcomplicating this, which I have a habit of doing. So let's just try and build out the vector, and we'll come back to this tomorrow. Okay, so whilst we do that, we can say, well, we can actually build our pair P. Let's actually look at how they use std pair here. Okay, so they do make pair. Oh, and they do auto. Okay. Make pair is also in utility, which is good. So we can say that our pair is we need to start at 1. Oops, I is 1. So I, but then also LHS minus I. And then we actually push that pair back into the vector. And then we can say that if I don't know, vec end the end is, what does this actually return? It points 1 past the last element in. Oh, okay. Okay, let's actually get size and then say may not be n itself. Yeah, I really do think I'm overcomplicating this. Just have this awful feeling. But yeah, like I said, I actually just want to print the vector and see if that's correct to begin with. So actually just want to do 4. So for that, we can just see out E first, and then a space. Then a line break, but then actually a copy of that, but doing second instead. Okay, we don't actually, I need to put the file in this folder. Unused variable, okay, that's fine. Let's do a.out, say 13. Oh, okay. I think actually my thing might be wrong here. If this is our left hand. It's our left hand side plus I. Yeah, the second element is the left hand side plus I. Okay, that looks better, but where is actually the left hand side gone? Because it's not 6. 6 is missing from here. Six and 13, I guess, are missing. What did it actually... wonder what it actually gave us for the result of the floor. Okay, it did give us 6, but it didn't quite build the vector as I thought it would. But that's actually fine, because that means we can pair up 6 and... 6 and 13 together. Wait, no, but actually, where's 12 gone? Yeah, 12 isn't there either. And that's everything in the vector. I think I might be missing this. Yeah, I am. Okay. Whoops. So what I meant to do is say that the vector at s minus 1 second is equal to n. So if it's true, to n, otherwise last element of vec s minus 1 second is not equal to n. Yeah, last element of vec 12 is not equal to vec 13. Okay, so I'm going to call it there and actually come back to this tomorrow. I'm going to just put some comments in here just about what we want to do. So alternate each pair to make the beautiful number. 1 G for something like 1, 7, 2, 8, etc. Do 1, 7, 2, 8. If last L vector is not n, then adjust. I'm just going to say adjust accordingly right now. I'll probably hate myself tomorrow for being for generalizing it that much. But yeah. Okay, so I'm just going to leave that there. Thanks again. Let's come back to this tomorrow. See you later.